This is part 3 of section 4.6. This is just a summary of all of our inverse functions, what it is equivalent to, and then the restrictions on the domain and the range, okay? And basically, I've put it together in a chart that's sort of like this. You're going to get answers in these two quadrants for cosine, secant, and cotangent. You're going to get an answer in these two quadrants for sine, cosecant, and tangent. And notice that sine and cosecant, so those are our reciprocal functions, and they give the answers in the same quadrants. Same thing with cosine and secant. It's just cotangent and tangent that are opposite. Okay? So, let's look at this. Use the 4-step procedure to find f inverse of x for the given one-to-one function. Okay? Now, what this is asking us to do is to remember how to find inverses. And what the first step to do is instead of f of x, you wrote y. And then you switched all of your x's and your y's. And then you solve for y. So here I'm going to add 1. X plus 1 is equal to 1/2 cosine of y. Now multiply everything by 2. 2x plus 2 is equal to cosine of y. And now this is the same thing as cosine inverse of 2x plus 2 is equal to y. Therefore, f inverse of x is equal to cosine inverse of 2x plus 2. Okay? So now, let's deal with this. Same basic idea. They want us to find the inverse of this function. Now, this looks a little bit weird, and that's just because of the phase shift for this. This is the domain that they've restricted it to deal with the phase shift. You don't have to worry about that too much. Okay? But I need to get this solved for find f inverse. So replace this with y. Make sure you keep these parentheses. They mean something very different if you drop them. Okay? Now we switch our x and our y. Let's get sine by itself, so divide both sides by 4. I have x over 4 is sine of 3y minus 2. Now we can use inverse sine. And we have the argument of sine by itself now. Now I need to add 2 to both sides. Okay. Now let's divide everything by 3. So that gives me 1/3 sine inverse of x over 4 plus 2/3 equals y. So your inverse function here is 1/3 sine inverse of x over 4 plus 2/3. Okay, now let's talk a little bit about some properties of these functions. Now we know about reciprocals, and we talked about how you can use the reciprocal function to get an answer, but you might need to make an adjustment. And we said you needed to make those adjustments here with tangent and cotangent, okay, because they are in opposite quadrants for the negative possibilities. And they say, you know, you're adding or subtracting, and that is, you can just follow the line across to the correct quadrant though. So this is technically what's going on. And you need to remember it if you're working something in general without an absolute angle to deal with, but pretty much that's it. Okay, and here even odd. We know that sine itself is odd. Well, so sine inverse is odd. Cosecant inverse is odd. Cosine is an even function. Inverse cosine kinda is an even function, but it's going to give you the answer in the wrong quadrant. So this is how you would make that adjustment. Okay. Same thing happens with secant inverse. It's kind of an even function, but you have to make an adjustment to put it in the correct quadrant. Okay. Tangent is odd. Cotangent, you have to make an adjustment for. Okay. So now I'm going to go through a proof. Now this is not something you're going to be doing a whole lot of, but it is kind of important that you start seeing these things. Okay? So show that sine inverse of x is equal to negative sine inverse of x for x less than or equal to the absolute value of x less than or equal to 1. Basically, they're asking us to show that this is an odd function. Okay? And then we're supposed to use that result. Okay? Now what I'm going to do is I'm going to define a theta that is equal to inverse sine of x. Okay, so I don't know what this is, but it's the answer to this. Okay, then by definition, we know that sine of theta is equal to x. Okay, and since this is inverse sine and we have to deal with the range, we know that theta is somewhere between negative pi over 2 and pi over 2. So far, all I've done is I said, okay, I'm going to let this stand for this. By definition, this means this and this. Okay? Now, we know sine is odd. So if I find sine of negative theta, this is equal to negative sine of theta. Definition of the fact that sine itself is an odd function. Okay. Now what I'm going to do here, I know that sine theta without the negative is equal to x, so I'm just going to make a substitution here. Okay, so all I've done is I've replaced x sine theta with x. Okay, now using the definition of inverse sine again, this tells me that negative theta is equal to sine inverse. Sine inverse of negative x. Okay, and what is theta equal to? Sine inverse of x. And that's exactly what we were asked to show, that inverse sine is an odd function. Okay, now let's use this to calculate this. Sine of pi over 3. Now here I have sine inverse of negative 1/2, and we've just shown that you can take this negative and move it into the front. So this is sine pi over 3 plus inverse sine of positive 1/2. What is inverse sine of 1/2? Sine is 1/2 at pi over 6. So this is sine of pi over 3 plus pi over 6. And that equals sine of pi over 2. What is sine at pi over 2? It's 1. So this is 1.